So this was one of our help box questions that people were wondering about. And basically what we're asked to do is we were just asked to find the derivative of this function. So that's all we're really looking for. And so this is really process. And instantly what I notice is this is a logarithm, okay, and not our nice natural logarithm either. This is a log base 2. And then B, there is an internal layer, and that internal layer I notice is a quotient. So I'm going to actually have to use quotient rule when I get to this. Now, before we take care of the outer layer, let's just go back and remember, like if we had like y equals log base 2 of x, keep in mind that our pattern, what we had noticed is that our derivative would really be 1 over, okay, ln of 2 multiplied by x. Now, I'm going to go ahead and rewrite that as actually x ln of 2. And remember, we'd really realize this because if we had something like, I don't know, like we'll say a of x equals e to the x, natural log of x, we had realized that, a prime of x in this case was really 1 over x. And the only difference in these was that, when we were using some other base, we had to kind of do a base change. And we realized where this came from, but we end up having to also divide by the natural log of the base that was there. And that accounts for the fact that this isn't a natural log, whereas this one was. So if I know this rule or this pattern, now I can go ahead and I can just, find my stuff over here. So if I'm going to go ahead and I'm going to give myself some more space, I know that if I'm taking the derivative of log base 2, which is all that orange stuff, I'm going to really have 1 over everything that was there, right? Because really we're kind of covering up all of that inner stuff. We're really covering this up, right? Like, so we're going to have 1 over all of that stuff. So x squared over x minus 1. And then it's going to be multiplied by, just like we have over here, right? Like ln of 2, because in this case the base was 2. And this is the derivative of that outer layer. Now I still need to take the derivative of the inner layer, and that's set up as a quotient. So I'm going to go ahead and use the quotient rule, and I know that's low times the derivative of the upper function, which is really 2x, minus the upper function times the derivative of the lower function, which is really just 1 in that case, all over the lower function squared. And that's the derivative of that inner function, which I had to use quotient rule on. And then after that, it's pretty much done, but it looks really, really ugly, right? So maybe this is why we wanted help with this one, is because it does look so hideous. So what I'm going to do is I'm just going to go ahead and explain some of my thoughts. I do a lot of this mentally, but I'll try to write it down more here for you. Right there, I'm going to view this as actually 2 separate fractions. I have this fraction, and I'm going to say it's multiplied by this fraction. And the reason I do that is so I can kind of see what's a constant, right? This is just a constant, so I'm going to be able to pull that out front. And then, I know that 1 over on that first term, right? 1 over really kind of reciprocates it. So I could really rewrite that as being x minus 1 over x squared, and then this is multiplied by 1 over ln of 2. And I'm flipping that to the front just because it's a constant. And then I still have all of this stuff multiplied by, everything that's in that purple. And so I'll keep that in purple for a second. I'm just going to distribute the 2x. So I'd have 2x squared, subtract 2x, right, and subtract x squared. And that's all over x minus 1 quantity squared. And then simplifying the top, I could really simplify that top, and I'll do my work over here at this point. So I'm still going to have my 1 over ln of 2 multiplied by x minus 1 over x squared, multiplied by, if we look, 2x squared minus x squared, that's going to be x squared. And then I'm still going to have my subtract 2x, not a big deal. And that's all over x minus 1 squared. Now notice I have not distributed out the bottom. I'm doing that intentionally. I'm only going to distribute things if I really feel like I need to. It's going to help me. And in this case, I don't feel like it is. especially considering I realize I have a factor of x minus 1 right there. And so that will cancel out one of the x minus 1s from the bottom, right, leaving us with just one of them. And so then ultimately that's going to give me, x squared minus 2x all over ln of 2 multiplied by x squared multiplied by x minus 1. That's still all grouped. And again, I realize that there's a factor of x in the top. I could really kind of factor an x out, or, if I really wanted to. And there's a factor of x in the bottom. So I'm going to cancel out one of those factors of x, and that's going to leave me with x minus 2 all over ln of 2 multiplied by x times x minus 1, which isn't so bad. And then ultimately, if I really want, I could distribute that x in the bottom. I don't really see if it's going to help me or not, so I'm not going to do it. And this is what I would say my derivative is at this point in time. Okay, I don't really see anything else that's going to really simplify in this case. So this is what I would have as my derivative function in this case. Hopefully it helps.